The diagram shows a circle with centre O and radius 8 centimetres. The points A, B, C and D lie on the circumference of the circle. Angle AOB is equal to theta radians and angle COD is 1.5 radians. The area of the sector AOB is 20 centimetres squared. So we want to find the angle theta. Well, we know if we're in radians, the area of a sector is a half r squared theta. So we know the area is 20, and that's going to be equal to a half times 8 squared times theta. So 20 is equal to 8 squared, 64, half that's 32 theta. Theta is going to be 20 divided by 32. And let's just cancel that down. So 20 divided by 32, it's 5/8 or 0.625 radians. You don't actually need a mark specifically for radians. Radians are just numbers. Find the length of the arc AB. Well, we know that L is equal to r theta. So that's 8 times 0.625. So multiply the last answer there by 8. And that gives me 5 centimetres. And the area of the shaded segment. Okay, so that's this shaded segment here. So that's going to be the area of this sector. Take away the area of the triangle. Remember, we know the radius is 8, so that's 8 and 8. So we are going to have that the area that we want is the area of the sector, which is a half times 8 squared times the angle, which was 1.4. Take away the area of the triangle, which is a half times 8 squared times the sine of 1.4 radians. So I need to make sure my calculator is in radian mode here. So, and I don't think it is. I think it's in degrees. So, I don't want that. So I need to be in radians. And then I've got 0.5 times 64 times 1.4. And we'll take away 0.5 times 64 times the sine of 1.4. And that's 13.27 square centimetres.